Hold on a moment. Let me. All right. So, if I said, what is the square root of 3 times the square root of 10, what would the answer be?
It would be I think I need a little refresher.
Well, what would you think? What would your obvious answer be?
I think it would be the square root of 3 times the square root of 5.
Well, now hold on.
Two.
Very first of all, if you have the square root of A times the square root of B, that's equal to the square root of A times B.
Okay.
Okay, so the answer here is square root of 30. Now, if I can simplify that, I will. But it turns out that I can't. Square root of 30 is simplified. In other words, it's not equal to, there is no factor of 30 that is a perfect square number. And remember, that's always what you're trying to do. Simplify this for me.
Sorry, hold on. Somebody's phone is going off. Okay, sorry about that.
All right. So this works in both directions. Okay? In other words, if you have the square root of the product of two numbers, it's equal to the square root of the one number times the square root of the other. And this is going the other direction. In other words, the square root of 3 times the square root of 10 is the square root of 30. And then if you can simplify that, do so. But if you can't, that's the answer. Okay? Now, here we're going the other direction. What's the square root of 50? Factor it. Can you find a factor of 50 that is a perfect square number?
10, so it would be the square root.
Hold on. 10 is not a perfect square number. What are your perfect square numbers? List them over here. Starting with 4. What's the next one?
6.
4 is 2 squared. What we're looking for is 3 squared.
9.
What's 4 squared?
16.
What's 5 squared?
25.
These are your perfect square numbers. Okay?
So
and you want to know those. You want to memorize those. Those are extremely important numbers when it comes to conquering algebra. So what we're looking for are there any factors of 50 where one of them is a perfect square number?
Yes, 25.
Okay, what's the other one? 25 times what is equal to 50?
2.
Okay, so it's the square root of 25 times the square root of 2. Now, that square root of 25 can be converted to an integer. It's the number 5. This cannot. That stays square root of 2. So that's how I simplify square root of 50. Okay?
Okay.
But notice when we had square root of 30, can't really break that down. There is no perfect square number that divides into 30, which means that's my answer, square root of 30. If I cannot find a factor that is a perfect square number, then I'm completely simplified. Okay? If I said the square root of 122, that's simplified. There is no factor of 122 that can be divided by one of your perfect square numbers. And that's the rule, is you just have to, you only simplify it if you can find a factor of a perfect square number. All right, let's see. This subject here is a big, big subject. When do you start back to school, Phoebe?
Thursday.
Next Thursday.
No, this Thursday.
This coming Thursday.
Yeah.
And you're going to start back in geometry, correct?
Yes.
And they're going to start you off probably by giving you a test of your algebra knowledge. Correct?
I'm not sure.
I'll bet anything that's what they do. And if you fail it, you'll get sent back to algebra. If you pass it, you'll be able to take geometry or something close to that. So we're not going to have a whole lot of time before you have to take this algebra test. We don't have enough time to cover all of these subject material. Not at even 2 hours a week. Well, let's just keep going in order. Then we'll get as far as we can get. Okay?
Okay.
I'll try to do these a little bit faster. So let's do this one here. Solving quadratic equations using square roots. Well, an example of that would be this. It's the first thing you could do here. That's a quadratic. It's got x squared in it. It does not have an x, but you don't need an x. As long as you have an x squared, it's a quadratic.
Would you add 25 to each side?
Okay, that works. I'm not positive that's the best thing to do. We'll see. Now what?
Take the square root of each side.
Okay, so what? Tell me the next line.
X equals 5.
Biggest mistake I see in algebra after 8 years of tutoring is what you just answered.
Is it plus and minus 5?
There you go. If only there were a song. And I guarantee you, you will lose points if you leave off the plus or minus. 100% of the time. There's no teacher in Colorado that's not going to deduct points if you do not put the plus or minus there. Now, pretty much the rule is whenever you're taking the square root of both sides, which is what you did here, you took the square root of both sides. Always begin your answer with the words plus or minus. Never, there are no exceptions. Okay?
Okay.
All right. So let's do one more. Try to get through this whole subject today. At least once. A lot of times, Gesundheit. A lot of times the secret of math is just, if you don't understand it, read it once, and if you still don't understand it, read it another time. I'm trying to become proficient at statistics this semester so I can tutor it. and I'm having to read the book numerous times. So let me ask you, what's the answer to this?
X equals plus or minus 7.
Very good. All right, let's go on. Completing the square. Let's talk about the 3 formats for a quadratic. You really, in order to even talk about this topic, we have to talk about the 3 formats, okay? So here's the standard format. Y equals ax squared plus bx plus c. Here is the vertex format. Y equals little a times x minus h squared plus k. And the third format is the intercept format, which is y equals a times x minus p times x minus q. Now, each of these formats is extremely important. In fact, I'm not sure which one I would choose as the most important. Probably what most students would choose is the vertex format. And the reason is if you have something in vertex format, you can immediately graph the vertex. In other words, if I'm looking at a vertex of 2, 3, and I know it goes up, I know the graph looks approximately like that. So vertex format's pretty valuable, but it turns out if you really want to learn about quadratics, the other 2 formats are just as important, particularly the standard format. In other words, if I tell you that y equals x squared plus 2x minus 5, and I ask you, where are the zeros of that? Your first inclination would be to try to factor it, right?
Yeah.
Factoring is always the first thing you want to turn to. But once you examine this, you realize that there are no factors of 5 that subtract to the number 2. Okay?
Okay.
So, whenever that is the case, which is really most of the time, I mean, it's really very few quadratics that factor perfectly. And what you're always looking for are where the zeros are. In other words, where is y equal to 0? And you have the quadratic formula, which I'm going to give you. And I don't know if this is your first exposure to it or not.
No, I've worked with it before.
Okay. Did they teach you a song?
No.
I suspect that you had not memorized it yet.
No.
There's probably no more important thing for you to memorize for math than this. So whatever it takes, do it. Okay?
Okay.
That's how important this formula is. Now, let's talk about what A, B, and C is. What's A? Given this is our function here, what's A? The coefficient of the x squared term.
So 2.
What's the coefficient of the x squared term? Not the x term. The x.
1.
Exactly. B is?
2.
C is?
5.
Minus 5. Okay, you see why it's minus 5? In other words, C is that whole thing. So you have to take the sign into account. So if we wanted to solve this quadratic, which we can't solve by factoring, and we can't solve by taking the square root of both sides, the only way to solve it is to use what's called the quadratic formula. Okay, so let's solve it. I'm going to write over here on the left. Let's just plug in. What's minus b?
Negative 1.
What's b?
1.
Look over here.
Oh, 2, sorry.
So it's minus 2 plus or minus, hold on a moment, let me get rid of this check mark. What's the next? In other words, this is really pretty easy. You just have to plug in the numbers. So what's b squared?
2 squared.
What's the rest of it?
4 times 1 times negative 5.
Now, all over what?
2 times 1.
Okay. Now, here's the problem. This really presents a lot of problems for students because when you go to evaluate what's inside the radical, you're looking normally at a minus sign there, actually always at a minus sign there, and sometimes a minus sign there. The difference is the first one means subtraction, the second one just is the sign on 5. So what I suggest everybody do is that first. That's your first step. Okay?
Okay.
And this may seem trivial, but trust me, it's going to save you a lot of mistakes. So let's continue. And this is always your first step. So write everything else for me.
It would be negative 20.
Negative 2.
Oh, negative 2 plus or minus the square root of 2.
2 squared. What's 2 squared?
2 4 minus negative 20.
Okay. So what?
So it would be 4 minus
4 plus 20.
4 plus 20. Okay.
In other words, 4 minus a negative 20 is 24. And that's why it's so very important that you do these in pieces. Everybody misses these because they try to do it all at once in their head. You do not want to do it that way. The part that I have circled on the right, always do that part first. Because usually it's a negative number. And if it's a negative number, then you're subtracting a negative number, which makes it a positive number. And that's very important because this number that's inside the radical sign really needs to be positive. If you discover that it's negative, you almost certainly have made a mistake, at least at this point in algebra. When you get to precalculus, you can talk about taking radicals of negative numbers, but you will not encounter that for the next 2 years at least. So if you find yourself trying to take the square root of a negative number, tell yourself you've made a mistake, go back, find it.
Okay.
Okay, and I still got to divide by 2. Now, let me see what I can do here. Hold on. Just a second. Let me go back over here. And we're not even going to talk about this method yet. Probably not even today. So here's what we got at this point. Okay?
Okay.
Now, the next step is always to see if we can simplify that. Can we simplify that?
No.
Actually, we can. Is there a factor of 24 that is a perfect square number?
Let me think.
What are factors of 24? Go through them. See if you can find one that is a perfect square number.
Well, it would be 4 and 6.
That's all you need. Okay. So what's that simplify to? What is the square root of 24 simplify to?
The square root of 4 times the square root of 6.
And now simplify that. What's the square root of 4?
2 times the square root of 6.
Yeah. Even though that's square root of 3 times square root of 2, you don't do that because neither one of those is perfect square numbers. However, notice now what we can do. Can I further simplify that expression?
Yes.
By doing what?
Solving the top part.
No, when I say simplify, think, is there anything I can divide top and bottom by that reduces the size of these numbers?
By 2.
Okay, what do you get if you divide top and bottom by 2? What's the top become?
-1 plus or minus 1 times the square root of 3.
No, you only divide one part. You don't divide it twice. In other words, when I'm dividing 2 root 6 by 2, I only divide the 2's. I don't do it a second time and try to divide the root 6. Okay?
Okay.
And I don't write the 1 because I don't need it. The first one I actually need. I cannot ignore that. But the second one I don't need. And the bottom is 1, and I don't need that either. In other words, when your denominator is 1, you don't write it. So that's the answer. And hopefully now you can see why it's really important to simplify these things. Because I went from a relatively complicated answer to a much simpler answer. -1 plus or minus the square root of 6. Now, what we just did was to solve this quadratic by using the quadratic formula. this part right here. And that's exactly what it is. It's just a formula. And you need to memorize it. I don't know. I don't have a song. I wish I did. I know they do teach people a song for the quadratic formula, much like, you know, the only way I ever learned my ABCs was A, B, C, D, E, F, G, H, I, J, K. I still have to go back to that song sometimes. Okay? So if you can find any assistance at all for learning the quadratic formula, do it. You need to memorize it. And you need to know what A, B, and C are. Let's talk about the middle part. We've done this part and we've done the last part. Let's talk about completing the square. This really isn't that hard. I think people make it much harder than it is. What was the last one we had?
Gosh, I don't remember. It was like
Plus x or minus x? I think it was minus x. Pretty sure it was minus x. Now, we solve this by the quadratic formula. But the quadratic formula actually is derived from the concept of completing the square. Okay? And I'm going to use a different function just because I think it's more useful if I use a different function here. Let's make it x squared. Let me think for a moment. Minus 8x minus 10. Okay. Now, let's go back and talk about vertex format. Vertex format is this. An example of vertex format might be this. Okay?
Okay.
So, there is a way to take this quadratic, which, again, notice it cannot be factored. There are no factors of 10 that subtract to the number 8. And that's always how you tell. Is you always look for that key thing that has to be. If this were to factor into two linear factors with whole numbers, then that would have to be true. And it does not. Okay? So if somebody said, well, tell me what the vertex of that function is, wow, it would be really terrific if we could put it into vertex format, which is what I have at the top. And the truth is you can very easily put it into vertex format. And what it involves is separating that and separating that. So you end up with this. Okay. Now you make sure that when you're completing the square, you're going to do it wherever the variable is. In other words, where I'm pointing right now, I don't think you can see it, but the left side of this x squared minus 8x equation. Okay?
Okay.
That's all you have to do is remember one simple rule. The way you complete the square is by taking half of the coefficient of the x term, which is what?
4.
Okay, and square it.
16.
Okay, and doing that. Now, I just changed the equation. I can't just go around changing equations. But how would I keep it exactly the same? If I subtracted 16 at the same time.
Okay.
Notice that I haven't changed anything. And that's always the secret when you're completing the square, is make sure you do not change the original equation with each step. Because all you're doing is manipulating it to put it in a different format. We're trying to get it into Vertex Format because it'll be more valuable to us in Vertex Format. Okay? And so when you go from line to line or row to row, the main thing is you do not want to change anything. Well, we didn't. We added 16 and we subtracted 16 to the same side of the equation. Okay? The beauty of that is the part that's in the parentheses can always be written now as whatever half that 8 was squared. Combine those two numbers, I get minus 26. I am now in perfect vertex format. Tell me where the vertex is.
-4 and -26.
It's actually positive 4 and negative 26. But that was good. That shows you're learning. Just get used to the fact that the vertex format is x minus h. So in this case, what is h?
4.
Positive 4, right?
Yeah.
That's the x coordinate of the vertex. So if I was going to graph this thing, my x coordinate is at positive 4. Where's my y coordinate?
Um.
You said it.
Wait.
Negative
Here.
20,
Yeah.
6. Okay.
Okay.
So let me go down on this graph, and I'm going to graph. That's positive 4, negative 26. That's my vertex. Okay. Now, which way does the parabola open? Does it open up or open down? What is A? It all depends on whether A is positive or negative. If A is positive, it opens up. If A is negative, it opens down. What is A? In this case, what is A?
1.
Correct. Positive or negative?
Positive.
Does it open up or does it open down?
Up.
Okay. So this is what my parabola looks like. And you can start to see why the vertex format is such a valuable format. Because you can start with the vertex. If you can get any quadratic function, and we started with standard format, if you can take standard format and convert it to vertex format, it's much easier to graph. You can start immediately with the vertex, the most important spot on any quadratic. Now, we may not have these 2 points exactly right. We didn't do more math, which we would have had to have done to figure out where our x-intercepts were. But still, you wouldn't lose full credit here for sure. Normally, when your teacher asks you to graph a quadratic, she's going to want 3 points. Some teachers want 5 points. But mathematically, 3 points describe a parabola. If you give me 3 points, there is only one parabola I can draw through those 3 points. So really, you only need 3 points to define a parabola. So you really never should need 5 points. They may ask for it, and I don't know what to tell you. But if you give them 3 points, you will be giving them an exact parabola that is exactly the same as if they gave you 7 points or 9 points. Doesn't matter. 3 points define a parabola. All right, let's see. Let me erase some of this. Just want to practice completing the square. Okay? We've solved equations with square roots. We've looked at the quadratic formula, which at this point I don't want to spend that much time on. Maybe next time we meet, we'll do some of that, although I see some other stuff here that's going to be important that you might get quizzed on in that first test. But I want to make sure you know how to complete this square. So I'm going to give you some more. First thing you ask, are there factors of 19 that subtract to the number 6?
No.
Okay. So, second thing you ask, I could use the quadratic formula on this, right?
Yeah.
What's A?
1.
What's B?
6.
Nope.
-6.
What's C?
-19.
Okay. What's the quadratic formula? And it always begins with x equal, because when you're solving the quadratic formula, you're really finding the x-intercepts, where it crosses the x-axis. Do you remember the formula?
Would it be
Do as much as you can, and sometimes you just have to remember stuff piece by piece.
okay? -b
Good.
plus or minus the square root of 4 times a times c. Oh, okay.
Well, I do that because that actually has its own name. It's called the discriminant. In other words, you'll reach a point in algebra, I don't see it on this page, but where they'll say, what is the discriminant of this function? And the discriminant does not include the radical sign. It just includes what's inside the radical sign. B squared minus 4ac. That's the discriminant. And the reason it has its own name is because if that amount is positive, then we have real solutions. If that amount is negative, we only have imaginary solutions. You haven't even discovered imaginary numbers yet. But trust me, it's important to know whether b squared minus 4ac is greater than, equal to, or less than 0. Each one has its own meaning. All divided by what?
2 times a.
Oh, perfect. Okay. And I'm just going to keep repeating it because, like I said, there's few things you're going to want to memorize more than that. This allows you basically to solve every quadratic, whether it's factorable or not. This is the most powerful thing you can use. even if a quadratic is factorable, if you use the quadratic formula, you'll get the same solution. Okay? So you can never go wrong by using the quadratic formula. But a lot of functions cannot be factored, like this one. So the only way I could try to solve for x, and when I'm solving for x, I'm solving for the x-intercepts, meaning y is 0, is with the quadratic formula. Now, let's say your test did not say solve for the zeros. Let's say that it said complete the square. Well, no, more put in vertex format. Put in vertex format. And the only way to do that is to complete the square. This part right here. And believe it or not, there are lots of places in math where you have to complete the square. It's not just when dealing with quadratics. Once you get to conic sections in Algebra 2, you'll have to complete the square a lot. It's a very common math procedure. So better you learn it now and, not stumble through the next 2 years trying to learn it. Let's learn it now. Okay? Well, this is what vertex format is. So what we have to do is put that in this format. Well, the first thing you're going to do is categorize this part right here. Anything that's got the variable in it. And leave enough room to complete the square. Now, did I change the function?
No.
Okay. What's the next step?
You do the half of 6, which is 3 squared, so it's plus 9.
It's always plus, incidentally. It's never minus. Because even if you get a negative number, when you square it, it turns plus. Now, I just changed the function, did I not?
Yes.
How do I get it back to its original form?
You add 9 to 9.
Not add 9, because I just added 9.
You subtract 9.
Gotta subtract 9. Now it's the same. It's exact. These two are equivalent. And that's the key. You never want to change it. The difference is that now I have that in the form where I can write it like that. How do I write that? As a linear function squared. What is it?
I'm not sure.
X minus, what is h, do you think?
Minus 6.
6 squared?
Minus 9.
36. What would h be?
9.
9 squared would be 81. Remember, h has to be squared to get that last constant term.
3.
Aha! And it's minus 3. Okay? In other words, if I take x minus 3 times x minus 3, I get x squared minus 6x plus 9. That's the whole point of completing the square, is so that I can write it in a linear term squared. Because now, notice that that's in vertex format. Tell me what h is.
3.
What's k?
28, sorry.
Minus 28.
minus 28. Okay.
That's plus k. So you have to take that sign. It's different than the h. Okay?
Okay.
What's a?
1.
Okay? So if I were to graph this, tell me where the vertex is.
It would be at 3 and at negative 28.
All right, call that 3 minus 28. Does it open up or down?
Up.
Good. Now, if I go back and look at my original equation, x squared minus 6x minus 19, what's the y-intercept?
So y-intercept?
Yeah, where does it cross the y-axis? I know I'm going to be looking at a parabola, right?
Yeah.
But if I want to draw it accurately, I need two other points. I only have the vertex. I know the vertex is where my dot is, and I know it opens up. But if I want to be a little bit more precise, the y-intercept is actually the easiest intercept to figure out. Because what's x when you're on the y-intercept? What's the value of x?
0.
So plug in 0 into this function. What do you get for y?
Into which function?
The original function. This one right here.
Okay.
Plug in 0 for x. What do you get for y?
Negative 19.
Always that constant. In other words, every term that has x in it goes to 0. So that constant is the y-intercept. So I now know that I have a point right there that I could label 0, negative 19. That's a second point on my parabola. I also know that this parabola is symmetrical with the y-axis, so there must be a point there, and that describes the parabola precisely. And that I've got 3 points, that's all I need. And now I didn't quite tell you how to figure out this point, but you know that this parabola is symmetric, right?
Mm-hmm.
So if I'm 3 units to the right, then this point here must be 6 units to the right. So that point right there has to be 6, minus 19. And I now have my 3 points on my parabola, which is all you need. I don't care. If the teacher asks for 7 points, give her 7 points. But if Einstein asked you to define a parabola, 3 points would do it. Okay?
Okay.
And this is just one of the values of completing the square, is that you can take a quadratic that is in standard format and convert it to a quadratic that's in vertex format. And once you get it in vertex format, it's much easier to deal with. In other words, I now have it in vertex format. I know where to start. I start at 3, minus 28. And I know A is 1. So I got a ton of information. So, and the only way to take standard format and get it into vertex format is by this principle of completing the square. Now, we covered a lot today in this last topic here. More than we should cover in 1 hour. We covered this topic here, all 3 parts of it. And we need to spend a little bit more time on that. 1 hour is not enough time to cover those 3 things. And each one of them is extremely important in algebra, whether you're Algebra 1 or Algebra 2. And don't kid yourself, there's very little difference between the two, okay? I would not know where to draw the line between Algebra 1 and Algebra 2. They're all kind of the same. So at some point, you're going to take Algebra 2. So it looks to me like a lot of the stuff covered on this is Algebra 2. And I don't want to waste too much of our time covering the Algebra 2 stuff, because I don't think you're going to be tested on the rest of this stuff. Some of it may be. Properties of exponents, yes, probably. We'll need to cover that for sure. But exponential equations, logarithms, all of that, sequences, if we have to not cover anything, it'll be that. All right. Phoebe, tomorrow I will not forget our appointment. Hold on a moment. Let me just make sure that I... It's at 1 o'clock tomorrow and 1 o'clock Wednesday, correct?
No, it's 1 o'clock tomorrow.
11 o'clock. 11 o'clock Wednesday.
Yeah.
Yeah. Okay. I will talk to you at 1 o'clock tomorrow.
Sounds good.
All right. Thank you. Bye-bye.
Yeah, bye.